This video is to prove that there was a time before the Big Bang. The main things we are discussing here are the formation process of the Big Bang Singularity and the interactions between energy and spacetime. We all know that the Big Bang was about 13.8 billion years ago, yet the universe continues to expand at an accelerating rate. We cannot imagine how big the universe is and how much it expands. The Big Bang was caused by a singularity that was created by a very strong gravitational, unified, interaction. We don't know how much energy was there inside the Big Bang Singularity. We cannot guess how many billions of years it took to store this much energy in the Big Bang Singularity. Naturally, we can see the presence of time for the formation of the Big Bang Singularity now itself. The universe is a great sanctuary of mysteries that we still do not understand. We still do not even know exactly how the universe originated. The origin of our universe is one of the most discussed topics in physics. Several theories have been put forward to explain the origin of the universe. Based on the evidence, the theory of the Big Bang is widely accepted now. But we still do not know what was there before the Big Bang. Let us try to understand more about this period. For that, we can divide the universe into two periods. The Big Bang can be taken as a focal point. Let us call the universe before the Big Bang the primordial universe. The universe created after the Big Bang can be called the present universe. To understand more about this, we need to know about the conditions before the formation of the Big Bang Singularity. It is important to understand the state of the energy at that time. We need to understand what space-time was like and how space-time and energy were related. How space and time were related in that period is also important. Many say, there was no time before the Big Bang. But I don't believe in that concept. In this video, I would like to discuss more the conditions of the energy, space, and time of that period that we still do not understand. Also, let us see how this state of energy is combined and how the singularity that caused the Big Bang was formed. We all know that, during the formation of this singularity, the Big Bang takes place at a certain point, and the time starts there. Two problems that confuse us begin here. Here we see the first problem that arises to confuse us. What is the time? Where was it? What was time at the gravitational singularity? Was it at a zero value? Or was it a part of the energy liberated by the Big Bang? Was there time before that? Still, we don't know what it is. We are running with the time or it is running with us. The second is more complicated. Why did the Big Bang happen at this particular time? Couldn't it have happened a little bit earlier? Or couldn't it happen after accumulating some more energy into the singularity? The same question often comes to my mind when thinking about star formation. Why do all the stars differ in size and mass? We explain it in many ways. But I have my own way to explain the reason for every phenomenon occurring in the universe. Let us start with singularity. In general, many people try to view singularity as a mathematical model. But we can say that singularity is possible because we already have evidence of the Big Bang. There are some misconceptions about the system of singularity. One of the most important of these is that the value of time is zero in singularity. I have to admit that it is true to some extent. The second is that there was no spacetime in the Big Bang Singularity. This is because of the way we understand the universe. We have already discussed how matter is accommodating in spacetime. Matter can never exist without the presence of spacetime. Most importantly, the Big Bang Singularity did not happen in just a moment. The energy that encompasses the entire universe has to concentrate in one place over a process of billions of years. So it must be said that there was the time before the Big Bang. Then how can we say that there was no time in the singularity? For that, we need to understand how energy and spacetime are distributed in the universe. The building blocks of the universe are spacetime and matter. This picture will help us to understand more. We are now trying to understand the distribution of energy and spacetime in a selected part of a system. From this, we can determine the size or volume of the system and the amount of energy and spacetime within it. The parallelogram in the picture is divided into two triangles. Triangle CFD and triangle EDF. Here I call triangle CFD as triangle HIR and triangle EDF as triangle URO. Triangle URO represents the distribution of time in the total system. Similarly, triangle HIR is the distribution of space in that system. These two triangles have a common side, and I call it R. The maximum distance at which energy and spacetime can interact is R. It is also the total distance that interacts with time and space within spacetime. We can see that the distribution of space and time inside the system are in opposite directions. We can see that the distribution of time increases with distance from the center. Similarly, it can be seen that the distribution of space decreases as it moves away from the center. We can see that they are both increasing and decreasing in the same proportion. As the distance from R to O decreases, the strength of the distribution of time is decreasing. I wish to call this distance as y. We can see that the decreasing strength of the distribution of time is moving closer to a zero value. Similarly, as the distance from R to I decreases, the strength of the distribution of space is also decreases, and I wish to call this distance m. So we can find a new equation here based on the picture. M plus y equals h. The sum of the distances from any point of R to I and O is h. Space and time combined together become the only dimension of space-time. If the rate of distribution of time decreases, the rate of distribution of space increases proportionally. That is, the energy, matter, is exerting its influence on the system is the same everywhere. So at each point of R, the effect of space and time will be different. That is, inside a system, time and space are distributed step by step along with energy. A quanta of energy can have a certain amount of spacetime of its own. Space and time will have been distributed in proportionally in that spacetime. So if you add one quanta of energy to a system, it will add a proportional amount of spacetime to the system. So we can clearly say that time and space are quantized. Here we can say that the system is also quantized, because energy is already quantized. Time and space are located within the quantized system. Let us look at the most center of the picture. There we see that the value of y, the distribution of time, is approaching to zero. Similarly, as the value of y increases, the value of m, the distribution of space, decreases to become zero at the end. That system ends here. On the space-time beyond that, the system will have no influence. The same thing happens with r. Apply an equal amount of force to each point of the distance from F to D, and when it finally reaches D, everything is over. Imagine that you have 100 coins in your hand. Imagine that you are walking in a street and you have 100 coins in your hand. If you throw a coin at each of your steps, you will not have a single coin left in your 100th step. The same thing happens in system. Energy is applying its strength equally to all parts of the system under its influence. Eventually, the interaction between energy and spacetime is completely eliminated. Similar things are happening in a singularity. As it approaches the center of singularity, space distribution becomes more, and distribution of the time becomes less. Finally, we can see that the value of time becomes zero. That is why we say that time ends at the singularity. To some extent, this is true. This is a flaw in our understanding of singularity. In all other contexts, we associate spacetime with the matter. But in terms of singularity, we are only looking at the matter. We must consider any object in the universe as an independent system. Now, whether it is an atom, a star, or a singularity, it is an independent system. All these have the same importance in the universe. A system of spacetime and matter. Matter cannot exist without spacetime, and spacetime cannot exist without matter. Both are two parts of that system. Although interrelated, spacetime is never a part of the matter. Matter just exists in spacetime. Let's look at the structure of an atom to understand more about this. We know that electrons orbit around the nucleus of an atom. We consider electrons to be among the fundamental particles called leptons. We can see that there is a lot of space or spacetime between them. If we look inside the nucleus, we can see protons and neutrons. While they are connected to each other, there must be a tiny space or spacetime between these particles. Protons and neutrons are made up of fundamental particles called quarks. When these quarks bind together, some space or spacetime remains between them. So far we have been able to understand up to this limit. That is why we call quarks and leptons fundamental particles. If quarks and leptons were to be real fundamental particles, they would not have spacetime, inside them. Only matter or energy is possible there. Then the particle will be in the smallest possible volume that a unit of energy can acquire. Here spacetime is completely outside of matter. Although spacetime and energy are co-related, they are two different systems. There is neither time nor space within matter. The singularity is also almost in this state. A singularity is a state in which space or spacetime within matter is completely eliminated, leaving only matter alone. Matter shrinks to the smallest volume that it can achieve. Therefore it can be said that there is no spacetime in the singularity. But since the singularity is only a part of a system, then it must be said that a singularity exists within spacetime. The operation of spacetime depends on the distribution of its two fields. The distribution of the time field increases as the distribution of the space field decreases. In effect, the time to the center increases with increasing distance. So the total strength of energy at the spacetime R is S equals R into m plus y, or S equals RH. This image describing the structure of spacetime is very important. We can describe the entire universe using this picture. Let's see how we can describe the famous equation of Einstein, E equals mc squared, using the same picture. Energy is described as the combination of two systems. Here m can be represented as matter and c square as spacetime. For each quanta of energy added to matter, a quantity of quantized spacetime c square is added to the system. This equation explains the entire universe itself. So the ratio between matter and spacetime in the universe is m is to c square. This same picture is the key to the theory of everything we are looking for. With this picture, we can unify all the dimensions of energy or matter. Now it can be understood that any form of energy cannot exist without containing spacetime. Now we can see the formation of the Big Bang Singularity to prove there was a time before the Big Bang. Let us examine the possibility for the gathering of the primordial particles together to form the Big Bang Singularity. Here we are discussing a general idea of it. Some of my other videos I explained 3 different possibilities for the formation of the Big Bang Singularity. One possibility is that none of these primordial particles were distributed in the primordial universe in an exact proportion. There was variation in the number of particles distributed in each region and the distance between them. Therefore, a widespread imbalance was evident in the primordial universe. Due to this imbalance and the lack of a precise criterion for the distribution of particles, there was a situation where the particles could interact. Things become much easier when gravity, the basic nature of the energy, was added to stimulate it. Wherever they are able to interact, these particles are attracted to each other with the help of gravity. The fusion of primordial particles, based on the theory of relativity, can explain in this way. 2 primordial particles form a curvature in spacetime at 2 different places and were combined together to create a slightly larger curvature. We can use this picture for more clarity. Picture, primary integration. This image represents the earliest structures, which are created by the attraction of energy, in the early universe. All the black regions in the image are clusters of different sized primordial particles that have coalesced at different rates in several phases. In the picture, we can see many black spheres of different sizes. We can interpret the formation of these spheres in 2 ways. First, we can say that many spheres have been formed in several places. Or it could be said that instead of having many spheres, there was only one sphere. That is, the primordial particles that were located in an unbalanced universe began to be concentrated in a certain part as a result of their gravitational pull. We can see this as the beginning of a gravitational singularity. I would like to explain things in the first way. Either way, we are finally coming to the answer to the Big Bang-based gravitational singularity. If we adopt the first method, we can easily find answers to more questions. We can present things like drawing a picture on a very large canvas. All these situations are well described in my book, The Key to the Secrets of the Universe. You can see the evolution of the universe from the primordial stage until the destiny of the expansion of the universe in my book. There you can see a lot of new ideas on the expansion of the universe and about gravitational interaction. I am explaining there how the expansion of the universe is undergoing another Big Bang. You can find the link to the book in the description box. Or you can visit our website www.akialone.com. Now let's see how the universe evolved into the Big Bang singularity. Let us see what happens when these particles merge around them. For example, suppose that two particles intersect. It is there eliminating the spacetime between them. As it grows more and more, we see a situation where spacetime disappears. Or we could say that it is a form that is located inside spacetime. Separate the spacetime and create a singularity. After the Big Bang, it expands into the same spacetime. Now we understand two things. How big was the universe before the Big Bang? How much spacetime is thrown out there to create the Big Bang singularity? Today our universe is regaining the spacetime it had lost for the creation of the Big Bang singularity. But this process is still going on for billions of years after the Big Bang. We can only imagine, then, how long it will take for the creation of the Big Bang singularity. The fact that the universe is still expanding means that the previously lost spacetime has not been recovered totally. Probably when it has absorbed enough spacetime, the universe will stop growing itself. In the early days, particle fusion took place very slowly. As the size of them increases, the gravity increases and the rate of this process increases. Thus particle groups were formed into many parts of the early universe. With the help of gravity, they are attracted to one another and thereby converge on the avatar. There was a time before that. We can say that a new time was born with the Big Bang. With the Big Bang, the energy begins to grow again into spacetime. At singularity, the energy did not encompass spacetime. Spacetime was out of singularity there. A spacetime will already be created there. If we look at the history of a particle in this way, we can split the time into several stages. A time until a particle remains in that state. When it merges with another particle, they start a new time together. Now it has two distinct timescales for that particle. Its initial time, and the new time, which it began to join with the other particle. Thus it appears that at each step until it reaches singularity, it begins a new time. But we can never say that it left its initial time. With the Big Bang, energy takes on a new form. Energy undergoes many changes and acquires all its other fundamental qualities, which it did not yet acquire before, and comes to a new form. At the same time, we can say that it is the beginning of a new time. According to the special relativity theory, we need to look at the concept of spacetime in detail. We can imagine two particles located in two different places in spacetime. Both of these particles distort spacetime in their own way. Suppose these two particles combine together. Then these two spacetimes combine together to become one spacetime. The integration of spacetime takes place along with the synthesis of energy particles. Just as energy is not destroyed during this process, spacetime is also not destroyed. Similarly, no more spacetime or energy is created. The atom, which is compressed by the strong gravitational pull of the black hole, expels the space inside it. Even if an atom falls into a black hole, it will work according to this principle. The energy particles inside the atom become part of the singularity and space is added to the spacetime of the singularity. The space within the atom and the spacetime distorted by its influence become part of the spacetime of the singularity. This same principle can be seen in the formation of the Big Bang Singularity. Here the elementary particles combined together and grew into the Big Bang Singularity. At the same time the spacetime under their influence also joined each other. The formation of the Big Bang Singularity was the result of joining the primordial particles one by one. Here the required energy is slowly stored. That must have taken billions of years. For gravity, we have two important theories. One was presented by Isaac Newton and the other was by Albert Einstein. Newton proposed in his theory that gravity as a pulling force. Einstein proposed gravity as the curvature of spacetime caused by mass and energy. In his theory, I perceive gravity as an attractive force in spacetime. In his equation, he showed us the curvature of spacetime on the left and the distribution of energy on the right. Every activity in our universe depends on the energy distribution in spacetime. All objects in the universe interact with each other by gravity. So gravity must be a force of attraction or repulsion. Newton shows us gravity as an attractive or pulling force. Both of these theories explain the gravity of a system. In any mode of any theory, we cannot say gravity is not a force. One can say gravity is the curvature of spacetime caused by mass and energy, according to the general relativity theory. But the inner meaning of this theory states gravity as a force. To understand the universe, we must first understand how energy exists in spacetime. For that, we need the ideas of Albert Einstein. Energy is located in spacetime in the same pattern he used to describe gravity. So I wish to explain the concept of curved spacetime in the general relativity theory that I understood in my observations, in a way that everyone can understand. In my vision, spacetime in general relativity is flexible. The flexibility allows the spacetime to fold, curve, following the effects of the energy distribution on it. Thus energy can pull spacetime closer to it from all of its sides. This energy can hang in the spacetime which it has pulled into it. Thus energy and spacetime are always subject to interact with each other. For a better understanding of this theory, you can imagine spacetime as the surface of an ocean. Imagine that you are traveling in a boat in this ocean. You can observe everything in general relativity at the ocean. There are waves, the curvature of the surface of the water by the mass of the boat, the shape of a vortex that we can compare to the event horizon of a black hole, and much more. We can have a very clear view of Einstein's spacetime concept from the ocean surface. We can see that the surface of the ocean is flat. So I would like to say it is a two-dimensional surface. We know that the mass of the boat can create a curvature at the surface of the ocean. When we are having this scenery, we are having the vision of a three-dimensional effect in a two-dimensional spacetime. Now imagine that the boat is sinking into the ocean. Here we can observe the three-dimensional spacetime of the ocean and all the parts of the boat are under the curvature of the ocean. In a flat spacetime, Einstein's theory of general relativity is giving us a three-dimensional vision of a two-dimensional spacetime. We are having an extra dimension here. When you are in the boat, you are adding your mass to the boat and it is applying the total mass to the surface of the ocean to create the curvature according to the total mass. Here the bottom of the boat is having direct contact with the surface of the ocean while you are not related to the surface of the ocean directly. Same as, when a spherical mass is acting with a two-dimensional flat spacetime to create a curvature in it, the bottom part of the sphere is having only direct contact with spacetime. The upper part of the spherical mass can't create a curved spacetime. Imagine that you have a sheet of paper and a small ball in your hand. You are trying to wrap the ball with this sheet of paper. You can wrap the ball, but can't do it perfectly because the paper will create some folding while it curves according to the ball. When the spherical ball or the boat sinks in the ocean water, there we can have a three-dimensional spacetime and it can easily wrap the spherical ball or the boat. If we ignore the gravity of the Earth in this system, ocean, the ball will not move to the bottom of the water. Somewhere in the water it can create a sufficient place. This is what is happening in space-time. Like this, all the objects in the universe, including our Earth, exist in a state wrapped by space-time. Energy, from all its dimensions, bends space-time into it and hangs on it. There is now a general understanding of the interrelationship between space-time and energy. This condition is the cause of gravity. In my opinion, gravity is an attractive force but a repulsive force at a distance. A mass can remain in space-time by hanging in curved space-time. This is the reason why gravity is repulsive to distance. With the help of the curvature of space-time, any mass can create an orbit in the curved space-time of a massive object. Each mass can create its own curved space-time. We know that the distortion of space-time leads to the free fall of an object to another gravitational field. Increasing the size of the mass will decrease the distortion field length, and the decreasing size of the mass will increase the distortion field of a mass. Black holes are the best examples of this phenomenon. Now we know that each mass has its own curved space-time and space-time distortion length. Here we can see that time is flexible to any dimension with the direction of the force. Energy is always concentrating on the center of the system and gravity is spreading around it. There it can create only an identical space-time with all the directions. Gravity is holding space-time to the center of the mass, and a mass can freely stay in space-time. In this geometry, gravity allows the mass to hang in space-time. It is revealed here that space-time is holding a mass in it by the effect of gravity. I can present a model of the solar system to illustrate how other objects remain in the curved space-time of a massive object. Every mass has its own gravitational field, so we can say every mass in space-time can create a curvature in space-time. We can imagine our solar system and we know that it is a complex gravitational system. The major part of the mass of our solar system is concentrated in the Sun, and all the planets orbiting the Sun. So like the Sun, every planet can create a curvature in space-time, according to its mass, energy in it. Up to this point is explained in general relativity. In my concept according to the above picture, mass is hanging in space-time by curving it by gravity in all dimensions. At this stage, we can say that the planetary motion around the Sun is due to the curvature of space-time. In the system, the Sun is curving space-time to the direction of the solar mass and the Earth is curving space-time to its direction. So we can see that those two spacetimes are curving in opposite directions. Two different curved spacetime in the opposite direction can create an orbit around the stronger spacetime. But the position of the Earth is inside of the curved spacetime of the Sun. So inside the curved spacetime of the Sun, Earth is creating another curved spacetime towards its position. In the same manner, the Moon is creating a spacetime inside the curved spacetime of Earth. This system allows even smaller objects, like asteroids, to orbit the Sun in spacetime. We know in our solar system, Jupiter is the biggest planet and Pluto is the smallest, but Pluto is orbiting the Sun even if it stays away from Jupiter. So even if the Earth's position has been changed in the solar system, it can orbit the Sun. Here we can see how gravity is creating a repulsion between two masses. Actually, the curvature of spacetime in opposite direction is causing this repulsion. To get a better experience, here we can imagine the above picture, a gravitational system. So the matter always holds its own spacetime with it, even if it is a singularity or a fundamental particle. So it is sure that there was a time before the Big Bang. For more information, you can read our book or visit our website. Aqualone is an individual research firm based in Japan. We focus on the theory of everything. Also, we create fascinating ideas to accelerate the technological growth of Type 1 civilization. We are creating favorable conditions for human society to enter the next stage of evolution. In all of our videos, you can find some interesting new ideas. You can see these things on our website. All of these are well explained in the book Key to the Secrets of the Universe. That is a simple book written in a way that everybody can understand the whole universe. There we are explaining the universe from the beginning stage. We start from the primordial coalition of two primary particles to form the Big Bang Singularity. Also, we are discussing many other issues in physics in the book. Or you can watch our videos for more information. All the links are in the description box. According to the rate of development of our technology, we are about to enter the next stage of cultural and social evolution. For that, we generate better ideas to enhance our technological growth. We work in all areas of the social and technological development of mankind. The availability of free energy is essential to accelerate the journey to a Type 1 civilization. Our aim is to make free energy available to all. Our main objective in this project is to fully utilize the solar energy reaching the Earth. For this, we are devising plans to rebuild the Tesla Tower and completely store solar energy. Our plan is to store solar energy and collect it in the smallest possible space. Using spacetime as a medium, we examine the possibilities of achieving an unpredictable velocity for our space travels. For that, we studied the changes that occur when a photon passes from one spacetime to another. Along with this, the solar system's movement inside spacetime was also studied. We understand that objects can move in two ways in spacetime. This possibility will bring revolutionary changes in our space technology. The same concept helped us understand why particles exhibit duality. You can see our journey to the Type 1 civilization in our book, How Can We Become Superhumans? This book mainly discusses how we should change socially and culturally under the new circumstances. We also discuss how to build a sustainable human society. Thank you for watching our video.